My name is Boshra Afra. I am the Research and Education Director with the Purdue Systems Collaboratory. I am a physicist by training. I did my PhD in material science and engineering, and I have a background in IT and web development. And while I was a PhD student at the Australian National University, I got to do a graduate certificate. And that opened my eyes into business, management, a very different world than physics. So I joined Collaboratory less than 2 years ago. And today I'm going to talk about what is the focus of Collaboratory, which is addressing grand challenges, working with complex problems with systems thinking approach. So to begin with, I just thought to have a look at grand challenges or wicked problems around the time I was born. This is like in 80s, early 80s. And you would have thought that 3 decades later, we are way more advanced in science, technology, education, pretty much in every area. And you would hope that we don't have many of these. But if you look at some recent years, these are in the past 3 or 4 years, you see, and these are only a few examples, this is just the tip of the iceberg. You see that, surprisingly, some problems have been a major issue back then, and still they are. And in this day and age, we still have water crisis in cities within the United States, the developed countries. Or we have the climate change problem, we have opioid crisis, we have vaccine problems. The other day I heard that there was a measles outbreak, and I quickly ran and checked if my son had the measles vaccines, and I was thinking, weren't we all notified about that? Didn't we all have access? And the outbreak is not just in other countries, underdeveloped countries, there is also in the US. So these things still keep coming up. Some of them, unfortunately, do not surprise us that much anymore, which is a very sad story. But thinking about these grand challenges and wicked problems, one thing to realize is these type of problems affect humanity at a very large scale. So when we talk about fatalities from this, we are talking about thousands, millions of people. And this is very common when you think about crises like this. Another thing to think about is that for solving or navigating these type of problems, we need way more than 1 or 2 or 3 areas of expertise. Take climate change, the science is there, the technology is there, we can't agree on political levels. Or for many other problems like that, there needs to be resolution coming from different areas of expertise from different sectors. And that is a big challenge for itself. Another thing, I want you to consider each of these problems as a system. So when we talk about climate change, when we talk about immigration, water access, think of it as environment, companies, government agencies, people. So there are a lot of elements, and then each of these elements probably have smaller elements under them. And each of these is considered a system for itself. Now, today I'm going to talk about complex systems when we consider grand challenges. And one thing that I wanted to distinguish is a difference between complicated and complex. And I put this slide up to start with simple systems, such as a clock, or whenever you build a system where when there is a recipe, there is some protocol you follow, you may need some level of technical expertise, you need to know some terminologies, but when you do that, and you master that technique, you can do this 1,000 times and it's going to work every time. This is a simple system. And then we have a complicated system, which has way more parts into it, and there are a lot of connections, and we can engineer these systems from scratch. It is complex because there has to be a lot of coordination between the parts and between the connection, and there needs to be a specific expertise just even for parts of this system. But imagine building a rocket to send it to the moon. When we do it a couple of times, or more than that, we learn from the experience and we realize that there are rules and protocols that we can put in place. And if we follow those and we look at the patterns of how the previous ones perform, then we can predict with some good certainty that this is going to work again next time. And that is a complicated system. But when we talk about complex problems, this is a whole new level. The predictability is very low, no matter how expert you are in one or the other field. We usually can't build these systems from scratch. There is a lot of interconnections, and these systems evolve because the parts interact with each other and keep changing. So the dynamics changes and evolves over time. And managing such a system is very different than a complicated one. And surprisingly, managers usually distinguish well when they have a problem which is complicated or complex. But when they want to come into action and implement some solutions, they usually draw from the type of management that we would do for a complicated system. And that is when systems fail, solutions fail. Now, examples of complex systems, imagine a flock of birds or networks. And when I talk about networks, this can be social networks, this can be a network of airports, for example. Imagine if each node is an airport and then the whole network of airport. This can be power network. And there are some common characteristics between complex systems. One is unpredictability. It's very hard to know what's going to happen next. These systems learn from its own history. So here, the system has a memory. And based on that, the system can evolve. There is a lot of relationship and interdependency between the elements. So you can't aggregate the behavior of elements and decide that the system is going to behave this way. There is an emergence behavior in these systems because of all the parts. And usually, the final behavior is not intended by individual parts. It's an aggregate. It's a different order, different level of behavior that emerges from these systems. These systems are non-linear, which means they have tipping points. Sudden phase changes can happen very rapidly. The system can be stable for quite a while, and then it can reach a very unstable status in a short amount of time. Think about revolutions, think about financial crisis. And again, so adaptive, unpredictable, evolving variations, these are all common characteristics of such systems. Now, when we deal with such a system, we need a new way of approaching these problems. We need a new mindset. And that is how system thinking has come about. I've put only 2 definitions here. There are many, many definitions of what systems thinking is. Some people assume that systems thinking and systems science is the same thing. Some would be very upset if they hear that. And there are different ideas, but nevertheless, some underlying principle is the same. I really like the first definitions by Barry Richmond. He's a system scientist, and he came up with that definition in 1978 or somewhere around there. He says systems thinking is the art and science of making reliable inferences about behavior by developing an increasingly deep understanding of underlying structure. He puts art and science together. Going back to how sciences and art or any discipline came to be many, many years ago, people were not used to work in a silos of discipline. There were mixed expertise that a person had. As science, technology, art evolved, then people became narrower and narrower and more professional in their field. And now we have all these things divided. But when we deal with complex systems, when all the other solutions of, okay, we're going to break this system into parts and address each part, and then that solution fails, we come to realize that we should not separate these areas. We should not separate technology, science, arts, communication, economics, history, management. We should not separate this when we are working for a solution to a wicked problem. It needs expertise from all these different areas. Now, systems thinking, there are people now that they do their whole PhD research on systems thinking. But the reality is that you need to have some foundational expertise. And when we talk about someone being a systems thinker, usually they are expert in one area. They could be engineer or a scientist, there could be a political science major, and they have this added skill. They have this mindset, they have this way of thinking, way of approaching problem that makes them a good systems thinker on top of this, the expertise that they have. And to tell you how this comes into effect when you think about, okay, I'm going to do a major and then I'll go to work either in academia or industry, non-profit sector, government sector. Systems thinking is becoming more and more interesting for companies because they realize that they keep hiring the best and greatest. And among this pool, there are some with some specific skills that they can deal with different projects, they can work with people from different areas. They bring a common language, a set of skills that helps resolving problems. And they could be from any expertise, but they have this extra skill. And that's why, as I did this search just a few days ago. If you search for systems thinking only on LinkedIn, this is only on LinkedIn, there are 1,500 jobs that ask for specifically this skill, and there are a variety of industries. I put few of the names. I couldn't possibly go through all the pages, but only by looking through few pages, I came up with these companies, and these are all major companies in different areas. I didn't put academic institutes here. I didn't put hospitals here. And when you think about systems thinking skills, it applies to every discipline. It applies to any expertise. And to see that, you can just do a job search and then look through the jobs, and you realize no matter what a specialty you have, gaining such a skill will be an advantage for starting a career path or for performing way better in any job that you start with. And interestingly, so at Purdue Systems Collaboratory, about a year ago, I needed to put together 2 proposals, which I describe later. But then I did a similar job search, and the number was around 700 jobs. And earlier this year, so about 5-6 months later, earlier this year, I did a similar thing for another presentation. The jobs were around 1,000. And a few days ago when I did that, I was like, I have 3 points on my graph to show that this thing is definitely increasing. For me, it's very interesting to do the same thing in maybe a few months and see how this is increasing, because more and more people realize that that good employee who fits well within the company and they always have comprehensive ideas and solutions have this skill. This is what we want. And as many of you know, many companies in the area and also nationally hire students, graduates from Purdue. And between the discussions that faculty members had with these companies, they realized that they are asking for such a training, for such an understanding from our graduates. So what happened, this was in 2015, a group of faculty members, deans of different colleges, heads of different colleges came together and launched the Purdue Systems Collaboratory. This is a photo from the launch day. It was a big event. Charles Bolden from NASA came. Provost Diba Dutta was very supportive of the initiative. And they created the collaboratory as a university-wide initiative that teaches, promotes, creates a community about systems thinking, about convergence of knowledge, and they identified four underlying principles for the collaboratory. The first one is convergence of knowledge. How can we bring faculty, staff, and students from across the campus? How can we bring people from liberal arts, from engineering, from economics and management together and start a dialogue to address the problems that not one or two disciplines can tackle by itself? Focusing our endeavors on improving the human condition. As I mentioned earlier, when we talk about grand challenges, human condition is the most important part because these problems affect people at a very large scale. How can we make sure people, which are students, faculty, staff at any level who are doing research or who are getting education at Purdue have this understanding to put human condition first and foremost in any problem? Enabling every Purdue student to have a systems perspective. When we talk about systems thinking, this mindset, this perspective is something that can be triggered in people just by practicing some at different levels. Maybe it's just a short course. Maybe the person then becomes very interested and they want to do a certificate. Maybe they then want to go and do research in this field. But how at a very beginner level we trigger this thinking? And we have like 40,000 students. So if a good portion of Purdue students graduate with such a perspective, this can have huge impact when these people go to workplaces, when these people give back to the community, and these are the next generation who are going to address grand challenges. So how can we give every student a systems perspective? On identifying foundational principles of systems, this is related to research, and similar to laws of physics that apply to any physics problem, the open question is that are there laws that apply to any complex system? And as many of you may know, sometimes if we have an open question, even if the answer is that no, there are no such rules, then that is a good answer. But we want to encourage research in this area to understand, and if the answer is yes, there are, what are those rules? Because there are a lot of common problems within different complex systems. Imagine healthcare and education. We have access problem. Imagine energy and water. We have sustainability problems. So what are those common laws that would apply to any complex system? And that is related to the research part. This is parallel to the previous slide. This is on our website as well. Earlier this year, we redefined our goals and we came up with 5 goals against how our graduates can be systems thinkers, how Purdue or Purdue Systems Collaboratory can be a place for credentials in systems thinking. Of course, for new graduates who want to enter a workforce, having skills is one thing, but you usually need to show something for it. A formal training, something that the students can demonstrate that they have done these courses or they have these credentials. How can we provide that? System science transformation and infrastructure for systems research goes back to research part. How can we do research in this field and create an infrastructure where people can put their results, put their algorithms, approaches, tools, methodologies, and then this be accessible within the community for everybody to take advantage of. And then how can we create a system science hub? By hub, we mean a community. How can Purdue becomes a place where people identify Purdue Systems Collaboratory with this community of systems thinkers? And there are many universities who are trying to implement programs with with respect to systems thinking, system science, credentials. One factor that distinguishes Purdue Systems Collaboratory is that we have full realization that this understanding should not be limited to one field. Usually such programs start with systems engineering and then systems thinking, and then it goes towards systems engineering. But for such a change, for such an impact, we really need to bring people from different areas together. We need to put engineers with political science majors, with communication specialists, with economists, managers, all in same classes and expose them to each other to be able to achieve such a level that when they end up working in a company or in a government sector, they can maintain those relationships and they speak the same language. This is one of the offerings, very new from the Purdue Systems Collaboratory. We have a certificate at the undergrad level, and this is a certificate at graduate level where students on campus can do the courses here, or we also have a lot of online students who take these courses. There are 3 courses. Perspective on Systems is being offered this semester, as well as Tools and Methodologies for Designing Systems, and next semester we have Practical Systems Thinking. And these courses were being offered since 2014. And the interest in the courses were great. So we decided that we can put these courses as a consistent flow of information and put together a certificate program. And the certificate program was just approved by the Indiana Commission of Higher Education early in the summer, and we were able to launch this program from this semester. So for anyone who resonates with these ideas and they think this is the way to go for solving major problems, and this is the way to position ourselves better in the marketplace, you can take advantage of this certificate, and you can start by doing courses or by enrolling for the certificate altogether. And there is more information about the certificate on our website. If you have any question, you can always also reach out to me. I know that, for example, in Perspectives on Systems, they cover topics such as for systems thinking, practical systems thinking, cybernetics. Dr. Ghani also started to introduce deep learning, Internet of Things, from this semester, and Dr. Kenley is explaining, for example, how to define a design problem, how to evaluate and identify stakeholders, how to come up with alternative solutions for different problems. And on our website, you can also see the flyers for these courses. And if you have done any of the courses before, it can count towards the certificate program. This is our website. You can go there, and so we have SYS courses, System Fellows Program, and System Certificate. This is the part regarding the graduate certificate. I briefly also want to mention the System Fellows Program. This is regarding research, and we advertised this assistantship, I think, early last semester. And the idea is that research students, either doing PhD or master by research, who are interested in systems-related projects. And when we talk about systems, this can be transportation system, social system, healthcare system, any system. It's really open to students university-wide. And the idea is that the student will work with at least 2 faculty members from different colleges, and the student will be the bridge to make sure that the research is going in both directions. So if you are working on developing a technology, you may have an advisor from political sciences who can guide you on how in reality this can be implemented and be applied. And then the fellowship has a funding structure, which is also explained on our website. And just a few days ago, we announced the winners for this round. We have 3 students, 1 from engineering, 1 from political sciences, and 1 from agriculture, ag college. And it was very interesting to see when we shortlisted the candidates, we really had a good number of very interesting projects. It was very hard to decide only on 3, but the level of work, the level of understanding that it's not enough to focus your PhD project only in one direction is already already we can see that on campus in different disciplines. And we are hoping that this program also incentivizes students to think about these ideas, work with faculty members from different expertise, and bring these expertise together, start a dialogue. Students in this area can have a huge impact on how we move forward with system science and system